right, hi everyone. Let's have a look at sprint number 15. So let R1, R2, and R3 be the three distinct roots of the equation x cubed minus 7x minus 1 equals 0. What is the value of R1 plus R2 to the sixth plus R2 plus R3 to the sixth plus R1 plus R3 to the sixth? Okay, so it's a cubic. We could find its roots if you happen to know the cubic formula. I've cheated on this one and put it into Wolfram Alpha, and it tells me that one of the roots is the following. So I think my general impression is we should not try the cubic formula route. Let's see if we can do this without finding the roots of this equation. Yeah, I've got rid of the answer choices because I think in general you should do multiple choice questions without looking at the answers. Helps prevent you from like tricking yourself into thinking you've got an answer that is not right. Anyway, right. So what do we know about R1, R2, and R3? Well, we know they are the roots of this equation. For each of them, Ri cubed minus 7 Ri minus 1 is 0. I being 1, 2, or 3. And then we also know all our Vieta's formulas facts, right? So our x squared term is actually 0, which means R1 plus R2 plus R3 is 0. Our x term is negative 7, so R1 times R2 plus R2 times R3 plus R3 times R1 is negative 7. That really is negative because they're in pairs, so any negations will cancel out. And then finally, our constant term is negative 1, so R1 times R2 times R3 is 1, because this time there's 3 of them, so we do get a negation, we need to flip the sign. Okay, that's a lot of facts. Which of them are going to be useful? Well, right now we can use the second one to change this thing that we're trying to find into a slightly nicer form. If R1 plus R2 plus R3 is 0, that means that R1 plus R2 is negative R3. So this thing that we're actually looking for is actually R3 to the sixth. And similarly, R2 plus R3 is negative R1, R3 plus R1 is negative R2. So we're finding R3 to the sixth plus R2 to the sixth plus R1 to the sixth. Terrible notation, never do notation like this, but that's what that says. Right, so this is a big power though. I don't like sixth powers in my equations. That's a little bit scary. So the way we're going to get rid of that is we're going to use this first equation because that gives us R3 cubed minus 7R3 minus 1 is 0. And we can use an R3 cubed to get an R3 to the sixth, right? So R3 cubed equals 7R3 plus 1, and similarly R2 cubed is 7R2 plus 1, R1 cubed is 7R1 plus 1. So we're going to change those. Obviously, if R3 to the cubed is 7R3 plus 1, then R3 to the sixth is 7R3 plus 1 squared. Okay, this is a slightly nicer expression, and actually at this point we can go ahead and multiply it out, and then hopefully bits of it will become these Vieta's formulas over here. This is not a super optimistic thing to hope for, because it is pretty symmetric, and our formulas are symmetric, so I think it's going to come together. Right, it comes out to that when you multiply it out. You can take my word for it, you can do it, it's a fact. We can use our first equation there, R1 plus R2 plus R3 is 0, just to get rid of that 14R1 plus R2 plus R3 term, so that's gone. And then we've got these squares in it. We can't get exactly that by squaring our first Vieta force equation, but we can get something pretty close. When we square R1 plus R2 plus R3, we get that. Yeah, the squares plus all the multiples twice. And we can use both of our first two equations to simplify that a bit. So on the left, we have 0. On the right, we have all of our squares, and then this thing 2 times R1, R2 plus R2, R3 plus R3, R1 is going to be negative 14, meaning this sum of squares is going to be 14, right? We've got that there, and we've got it up here, bolded in both places. And this expression up here, 49R1 squared plus R2 squared plus R3 squared plus 3, that's the thing we're trying to find. So we're going to substitute in the sum of the squares of the roots is 14. 49 times 14 plus 3, and that is 689. So that's our answer. Let's go back and see if it's any of the answer choices. Hopefully it is. If not, we'll have to revisit things. But there it is. I've actually managed to not write all over it, and that's answer B.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.